Welcome to qnawire.
Hi, in this case what we have is two different compounds. First of all, oct-1-en-3-ol, which is a ketone with the following formula. We're going to have the first carbon, double bond, 1, 2, 3. Here we're going to have the ketone functional group, and then we're going to count up to 8 carbons in their molecule. So 1, 2, 3, 4, 5, 6, 7, 8. That a compound that is a mosquito attractant can be generated by reduction of this compound. That means we're adding hydrogens into an alcohol that is going to have a very similar formula, but instead now we're going to have an OH here instead of the ketone. So what we want to realize is that over here we have a pi system of conjugated electrons, which comprises the ketone group and the diene here. Remember that here we have all sp2 carbons, and in this case we only have two sp2 carbons. So the absorption spectrums are going to be different. In this specific case, what we see is that oct-1-en-3-ol is going to have a maximum absorption peak at 219 nanometers, max absorption peak. And as this molecule is being reduced to the alcohol, the peak disappears. So what you're going to see when the reaction is happening is that as oct-1-en-3-ol is being produced, the peak is going to decrease in height. So at the beginning of the reaction, your absorption spectrum is going to look like this. We're going to have our absorbance with respect to lambda. Let's say that over here we have the 290 nanometer mark. At the very beginning of the reaction, you're going to see a big peak here. I'm just going to omit all of the other potential parts of the UVB spectrum. And since the absorbance follows Lambert-Ambien law, remember that it depends on concentration, as absorbance is equal to a molar absorption coefficient times the concentration times the optical path that is being traveled. The optical path is going to be always constant. So at the midpoint, the absorption is going to decay to half of what it had initially. So the peak reduces in height. And finally, at the end of the reaction, since all of the ketone has been consumed, you're going to see no peak whatsoever. And that's how you can follow the reaction using UV spectroscopy. That would be all, and have a good one.